let's go to Neo4j. So again, Neo4j is the leading open source NoSQL native graph database. When we say native, that just means that some graph databases, it's really just an implementation, or it's just a middleman wherein underlying it is a relational database, and then they just have like this code where on top of it that makes it looks like a graph database. But this one, Neo4j actually really converted this. So the way it stores it in the computer is as an actual graph. And the benefits of Neo4j, so first, it has the Cypher query language. So Cypher query language is, we will discuss this a bit later, but you can see that it is very intuitive. And there are also like works already, like there's an open Cypher query project wherein they're working on making this language more open so that many people can use it. And then, it implemented graph algorithms, and so it really has like fast graph traversals. It has a flexible property graph. I'll get to it on the next slide. And then there are drivers or libraries for many languages. So it has Python, JavaScript. Name that language, I think they have it. And so that means, it's easy to integrate in your code. So it's easy to integrate Neo4j to your code. And so here is the property graph model. So when we look at graphs, it really has two components. So it has the nodes and it has the edges or the relationship. So that connects the nodes. So nodes, they're usually tagged with labels, or as I call it, the types or the kind, wherein you're trying to say that what the role of that node is. For example, these nodes, we know that these are author nodes. We can also have nodes for genes. We can also have nodes for diseases, etc., etc. So you can define that, oh, this node is this type. And it can have properties. So, for example, it has the author name, it has like the author institution, and these nodes can also be indexed and constrained in Neo4j. So this just means that you can just improve the performance of querying these nodes easily since it is indexed and constrained. So relationship, on the other hand, so we know that this is the connections between two nodes. So that relationship for Neo4j will always have a source target, which is this, and a target node, which is this. So source node and a target node. And so there is some sort of directionality there, but it does not really affect navigation. We can see later when we discuss Cypher that this directionality, you can be agnostic with it when querying. And one thing with these edges is that they can also have properties. So for example, here we know that the paper is paper 2 and then the journal is NAR. And one good thing about this is that nodes can have multiple edges without having or without affecting the performance. So you can collaborate with like multiple authors, and the performance should not be that affected. So now let's try setting up a Neo4j instance. So from here on forward, this will be more or less, you can try this. I don't know if we have time to like do this today, but you can also like play around it on your own. But yeah, so we can try to set up a Neo4j instance. So installation for a Neo4j is available here. So if you click on that, so you can choose your respective OS and you can install it. Or alternatively, we can actually use this Docker container or this Docker image for Neo4j. So just a brief introduction to Docker. I'm not sure if you had this previously, but the basic idea for Docker is that Docker has these containers. So it's like a shipping company wherein you can ship these containers, wherein each container hosts an app, and all of those app and that container contains all of the requirements to have that app running. The good thing about this is that you can ship this container to different I can use this container. I have a Mac. If you have a Windows, if you have Linux, you can use this. So it's sort of agnostic with the platform, and that's why it's sort of easier to work on using Docker images, because you don't have to worry about installing prerequisites, or if it works on your system or not, because that's the idea. It ships to you, you download it, you install it, and then it should just work in your system. And yeah, so to start, so the prerequisite is that we will be using this repo. And since I assume that you already have a lecture with Git, so I won't go over this, but you can install Docker, and you can just download whatever Docker or Docker instance or Docker desktop for whatever platform that you have. So once you have that, slideshow. So you can clone the knowledge graph demo, and we can start running Docker Compose.